In this video clip, we will talk about root of equation and 0 point of a function. For example, previously we have this algebraic expression 2x squared minus 6x plus 4. If we let this expression equals f of x, then f of x equals this expression will be the function. We may also let this expression 2x squared minus 6x plus 4 equals 0. Then this will be the corresponding equation. Okay. And if we recall that when x equals 1, we plug into the expression, we should have a 2 times 1 squared minus 6 times 1 plus 4 equals 0. Then for x equals 1, it has two different names. For the equation, it is called the root. For the equation, x equals 1 is called the root of this equation. And for the function, it is called the 0 point. Of f of x, because you plug in 1 here, then you will get the whole expression be 0. Okay, so when x equals 1, we will have a f of 1 is x equals 1, f of 1 is 0. This basically tells us 1, 0 is on the graph. And we know y coordinate is 0, so this point is on the x-axis. So this point is also called the intersection between the graph y equals f of x and x-axis. So sometimes we also call this is the x-intercept. Okay? X-intercept. So for this x equals 1, it has 3 different names. One is x-intercept, another is 0 point for function, and the third name is the root solution, real number solution, or the root of the equation. Remember, when we talk about equation, means there is an equal sign connecting two expressions. When we talk about the functions, is that we let y be the expression. F of x in this case is this one. Okay, now we do more things. If we look at this example, then we were asked, is there any 0 point for this function? Log, natural log plus 2x minus 3 on interval 1, 3, close interval from 1 to 3. Here is the way to do it. First, we consider the value when x equals 1. 1x equals 1 here. If x equals 1, we plug in to the expression. We get -1, because the natural log 1 is 0 value. Okay, this one is 0. All right. And then 2 times 1 is 2 minus 3, so we have a negative value. And the picture is that when x equals 1, here we have a value y is -1. And if we plug in x equals 3, then f of 3 will be natural log 3 plus 2 times 3 minus 3. 2 times 3 is 6, minus 3 is positive 3. If we calculate this value, natural log 3 is also greater than 0. So basically what we get is when we plug in the value 3, here we should have a value approximately greater than 4, which is positive. And then the function is continuous. From 1 to 3, it is continuous. So this line or this curve must go through the x-axis. So we do not know exactly where this point is, but we know one function value is negative, another is positive. Then in between 1 and 3, the line or the curve must go through the x-axis. Then we can claim there is a root for the equation. Okay, or we may claim there is a 0 point right here. There is a 0 point. For the function f of x equals natural log equals the natural log x plus 2x minus 3. Okay. So, what's the general statement? Here is the general statement. The general statement says that for function y equals f of x, for function y equals f of x, if it is continuous, means no gaps, no jumps, on interval AB, and the product of f of a times f of b is less than 0. Less than 0. Less than 0 means what? Means signs are different. Signs are different. Okay? So in our case right here is we know f of y is negative 1, negative. F of 3 is here is less than 0. F of 3 is a value which is positive. So then, of course, the product will be y is negative, y is positive. The product of these two values should be negative. Okay. There are cases is that f of a might be greater than 0 and f of b might be less than 0. There are cases probably like that. A here, B here. F of A can be greater than 0, and f of b can be less than 0. In this case, the product of these two values can still be less than 0. Okay, so the line must go across the x-axis. Okay, so that's why we said the signs of a, f of a and f of b are different. Then we may claim that there is a 0 point for function y equals f of x in interval from a to b, or we may say there exists c in interval ab such that f of c is 0. Okay, and then we may claim c is the root for the function f of x equals 0. All right? Okay, I'll see you next time.